How to improve memory utilization in Oracle database. Improving memory utilization in an Oracle database involves optimizing the configuration and usage of various memory components. SGA, System Global Area, Configuration. Increase the size of the SGA to allocate more memory for Oracle's data buffers and caches. This can improve performance by reducing disk I/O. Adjust the sizes of individual SGA components like the buffer cache, shared pool, and large pool based on your workload and system requirements. PGA, Program Global Area, Configuration. Increase the size of the PGA to allow for more memory allocated to each session's private work area. Consider using the automatic PGA feature, which allows Oracle to manage PGA memory allocation automatically. Shared pool. Monitor the usage of shared pool components such as shared SQL areas and PL/SQL procedures. Use tools like $SQL and $SQLArea to identify high-resource consuming queries. Tune the shared pool by adjusting the shared _pool _size and shared _pool reserved size parameters. Memory management parameters. Set appropriate values for memory-related parameters like db_cache size, shared _pool size, java _pool size, and large _pool size. Consider using automatic memory management, AMM, to let Oracle dynamically manage memory allocation. Automatic memory management, AMM. Enable automatic memory management to allow Oracle to dynamically distribute and manage memory across SGA and PGA components based on the workload. Configure the memory_target and memory_max_target parameters to set the memory limit for Oracle's use. Buffer cache. Properly size the buffer cache, db_cache size, to reduce disk I/O and improve performance. Monitor the buffer cache hit ratio, $systat buffer cache hit ratio, and adjust the size accordingly. Redo log buffer. Increase the size of the redo log buffer, log_buffer, if you frequently encounter log buffer space errors. This helps to handle high transaction rates and reduce I/O. Use result cache. Utilize the result cache feature to store frequently executed SQL query results in memory, reducing the need for re-execution. Monitoring and tuning. Regularly monitor memory-related statistics using tools like Automatic Workload Repository, AWR, Enterprise Manager, or custom scripts. Analyze performance metrics and identify memory-intensive operations or memory-related bottlenecks. Tune memory parameters based on workload patterns and observed performance issues. How to improve Oracle goldengate extract lag. To improve Oracle goldengate extract lag, optimize network bandwidth. Ensure that your network bandwidth is sufficient to handle the data replication traffic between the source and target systems. If the network bandwidth is limited, it can cause delays and increase extract lag. Consider increasing the network bandwidth or optimizing the network infrastructure. Monitor and tune extract parameters, review and adjust the extract parameters to optimize the performance. Some parameters to consider are EXTTRAL and DISARDFALE. Ensure that the extract trail and discard file are located on fast and reliable storage systems to minimize I/O latency. FETCHOPTIONS. Adjust the FETCHOPTIONS parameter to control the number of rows fetched per transaction. Experiment with different values to find the optimal setting. Commit log. Set the commit lag parameter to a suitable value based on your system's requirements. This parameter determines the amount of time the extract waits before committing the transaction. Optimize disk I/O. Poor disk I/O performance can cause extract lag. Ensure that the disk subsystem for the goldengate trail and other related files is fast and responsive. Consider using high-performance storage technologies such as solid-state drives, SSDs, to improve disk I/O. Parallelize extract processing. Goldengate allows you to parallelize extract processes to improve performance. By splitting the work among multiple parallel extract processes, you can reduce the load on each individual extract and potentially decrease extract lag. This requires careful planning and configuration based on your system's capabilities. Monitor and tune database performance. Ensure that the source database is optimized for performance. Monitor the database for any bottlenecks or performance issues and take appropriate measures to address them. This may include optimizing SQL queries, indexing, and database configuration. Upgrade goldengate version. If you are using an older version of Oracle goldengate, consider upgrading to the latest version. Each new release often includes performance improvements and bug fixes that can help reduce extract lag. Monitor and resolve bottlenecks. Continuously monitor the goldengate environment to identify any bottlenecks or issues causing extract lag. Use goldengate monitoring tools such as goldengate Monitor or Oracle Enterprise Manager to gain insights into the performance metrics and troubleshoot any problems. Review source system load. Analyze the workload on the source system. If the source system is heavily loaded or experiencing high resource utilization, it can impact the extract performance. Consider offloading non-essential or resource-intensive operations from the source system to minimize the load and improve extract performance. Optimize network latency. If you are replicating data across geographically distributed systems, network latency can contribute to extract lag. Consider implementing network optimization techniques such as WAN acceleration or using dedicated network links to reduce latency. How to improve Oracle goldengate Replicat lag. To improve Oracle goldengate Replicat lag, optimize network performance. Ensure that your network infrastructure is capable of handling the replication traffic efficiently. Check for any network bottlenecks, such as high latency or bandwidth limitations, and address them accordingly. Consider using dedicated network connections or increasing bandwidth if necessary. Improve disk performance. Replicat lag can occur if the disk I/O is unable to keep up with the replication workload. Ensure that the disk subsystem hosting the Replicat files is optimized for high I/O performance. Consider using faster disks, example solid-state drives, or RAID configurations to enhance disk throughput. Adjust Replicat parameters. Review and adjust the Replicat parameters to optimize its performance. Some key parameters to consider include: maxtrans. Increase the maxtrans parameter to allow Replicat to process more transactions in parallel, which can help reduce lag. Batchscale. Adjust the batchscale parameter to control the number of DML statements processed in a single database transaction. Increasing this value can reduce the overhead of committing transactions and improve Replicat performance. Parallelism. Set the parallelism parameter to enable parallel processing of replication tasks. This can be particularly useful if you have multiple CPU cores available. Monitor and tune Oracle database. Ensure that the source Oracle database is properly configured and tuned for optimal performance. Monitor the database for any performance bottlenecks, such as long-running queries or excessive locking, and optimize them to minimize the impact on goldengate replication. Avoid long-running transactions. Large or long-running transactions can cause Replicat lag. Identify and optimize such transactions by breaking them into smaller, more manageable units or optimizing the underlying SQL statements. Monitor Replicat lag. Regularly monitor the Replicat lag using goldengate monitoring tools or by querying the Replicat status. This will help you identify patterns or trends and take proactive measures to address any issues that may arise. Hardware upgrades. If you have exhausted all software optimizations and still experience significant Replicat lag, consider upgrading your hardware infrastructure, such as increasing CPU power, memory, or storage capacity, to better handle the replication workload. How to make Oracle RMAN backups to run faster. To make Oracle RMAN Recovery Manager backups run faster, optimize disk I/O. Ensure that the backup destination disk has fast read and write speeds. Consider using high-performance storage options like solid-state drives, SSDs, or RAID configurations to improve I/O performance. Parallelize the backup. RMAN allows parallelism, which enables multiple channels to work simultaneously during the backup process. You can increase the number of parallel channels to take advantage of available system resources. This can be achieved using the configure device type disk parallelism command in RMAN or by setting the parallelism parameter in your RMAN script. Enable incremental backups. Instead of performing full backups every time, consider using incremental backups. Incremental backups only back up the blocks that have changed since the last backup, reducing the amount of data transferred and improving backup speed. You can use different levels of incremental backups based on your requirements. Compress the backup data. RMAN provides the option to compress backup data, which can significantly reduce the size of the backup files. Compressing the data reduces the I/O required for writing the backup files, leading to faster backups. You can enable backup compression using the configure compression algorithm command or by setting the compression parameter in your RMAN script. Allocate sufficient channels. Ensure that you allocate an appropriate number of RMAN channels to maximize backup throughput. Insufficient channels may underutilize system resources and result in slower backups. You can configure the number of channels using the allocate channel command in RMAN or by specifying the channel parameter in your RMAN script. Use incremental merge. If you perform frequent incremental backups, you can periodically merge them into a single backup set using the backup incremental level 1 cumulative command. This consolidation reduces the number of backup pieces and improves the restore process. Exclude unnecessary data. Identify and exclude unnecessary files, tablespaces, or objects from the backup to reduce the backup size and duration. For example, temporary tablespaces or large, static data files may not require frequent backups. Schedule backups during low load periods. Plan your backup schedules during periods of low database activity. This helps minimize the impact on the production environment and allows backups to complete faster. Use Fast Recovery Area, FRA. The FRA is a disk location managed by Oracle, designed specifically for managing backup and recovery-related files. Utilizing FRA simplifies backup management, improves performance, and provides features like automated deletion of obsolete backups. Regularly maintain RMAN repository. Perform regular maintenance on the RMAN repository by running the delete obsolete command. This removes unnecessary backup pieces from the repository, optimizing its performance and improving subsequent backup operations.